Okay, this is topic 5 review. Again, this section was all about triangles, points of concurrency, and then also our inequalities within triangles. So the first essential question there, you could have answered that many different ways. And if you said anything about the points of concurrency, things about how the sides actually relate to the angles, like in one triangle, you have a side, the biggest side is across from the biggest angle, smallest side is across from the smallest angle. Everything that we talk about in this section, it relates back to that essential question. So anything will work, pretty much. Now for the vocab, we had a few different things. Now, number one, it said the blank is the point of concurrency of the angle bisectors. The angle bisectors all meet at the incenter. So that first one's incenter. 3 or more lines that intersect at one point are points of this is specifically talking about lines. 3 or more lines that meet at one point are concurrent lines. I would put concurrent lines, not just concurrent, but concurrent lines. The point at which they actually intersect is the point of concurrency. The point of concurrency of the altitudes of a triangle is the orthocenter. So orthocenter is this one. Orthocenter. A perpendicular segment from a vertex to a line containing the opposite side is the blank of the triangle. So perpendicular segment from the vertex to the opposite side, that is our altitude. A point that is the same distance from 2 points is equidistant. Where is it? There it is. Equidistant. A blank of a triangle has endpoints at the vertex and at the midpoint. That's a median. And you have to know your vocabulary. We've done the vocab quiz twice. Again, I still think you guys need to study a lot more on that because you need to know your vocab. Some of the questions are very similar to this, where you have to give in a statement. It might be a description. It might be one of the special properties. You have to know what vocab word goes with them. Okay, on the next part, number 8. Use the given values to find each of the unknowns. So on this triangle, now 8 is its own question, 9 is its own question. So you might have to rewrite some of these values. So it says if PS is 36 and PQ is 3x plus 5 and QR is 6x minus 10 and RS is 36, then what is PR? Well, they gave us enough information to say these two are congruent. So this point is on the perpendicular bisector, which means that this segment is being bisected, therefore these two are congruent. So we can set those two equal, solve for x, plug it back in, and solve for PR. So we have 3x plus 5 equals 6x minus 10. Subtract the 3x off of this side, we got 3x. Add 10 to the other side, we get 15. Divide by 3, and x is 5. Once you know that x is 5, you have to plug it back in to either one of those pieces. Doesn't matter which one, you should get the same number. 3 times 5 is 15. 15 plus 5 is 20. So each of those are 20. So PR is a total of 40. Now, for the second question, you actually have to redo some of this. So instead of rewriting it all, I'm just going to do it in a different color so that we can see what they're giving us. This time they're giving us PQ is 29. And they also told us that RQ is 29. So then they give us some measurements over here for the other side. So they tell us that RS was 5x minus 3, and PS is 4x minus 8. So it's kind of the exact opposite. This is the converse of the last one. We have our two pieces were switched, so we knew that these were congruent on the first one, therefore these are congruent. This one's the opposite. These are congruent, therefore these are congruent. So we're going to set those two that are in red there equal to each other and solve. So we now have the 5x minus 3 equal to the 4x minus 8. Subtract 4x off of this side, you just have x. Add 3 to the other side, you have negative 5. So it's okay that we have a negative value for x, We just can't have a negative value when it comes to our final length. So let's see. Let's double check and make sure I didn't plug anything in wrong either. So that was 5x minus 3, 4x, plus 8. So we do have to make a correction. That was a positive. So we're adding 3 to a positive 8, not a negative 8. So that gives us 11. So that's going to change our value. So now that we know that's 11, plug it back in. Doesn't matter. You could plug it in for either one. They're going to be congruent, but PS is the one we're solving for. So 4 times 11 is 44. 44 plus 8 is going to be 52. So 52 is our final answer. On 10 and 11, they both share this same figure. Again, same idea. This one's an angle bisector. We have JM is 12. LM is 12. And it says that where is it? So that angle here, JMK, is 25. That should be in degrees. They forgot their degree mark there. What is KML? Well, they should be congruent, so that should also be 25. So that was pretty straightforward. Number 11, they gave us different values. So this time, measure of, let's see, JML. So the whole thing is 49. They gave us, one of them was JMK by 4.5. So knowing that and knowing this, we can say that, hey, if this is half of that, this must be the other half. Therefore, these lengths must be congruent. And they told us that JK, actually, they're going to mark these two. JK is 17. So those two would also have to be congruent. This has to be 17. So again, there's lots of different ways you can be given information on that type of diagram, but it's all about which ones are congruent. All right, number 12. I did this one in class, but let's do it again. A point on a perpendicular bisector is 7 centimeters from each endpoint of the bisected segment and 5 centimeters from the point of intersection. What is the length of the segment? No diagram drawn, so we're going to draw one. So draw a segment, draw a bisector for the segment, label the length that they give you. So it says that point is 7 units away from the endpoints, and it's 5 units away from the point of intersection. That is a right triangle there in the middle, so we can use Pythagorean theorem, where 7 is our hypotenuse, 5 will be one of the sides, and then we'll call the other side temporarily B. But that's not what we're solving for. We need the entire length of that segment. So we're going to have to double it at the end. 7 squared is 49. 5 squared is 25. Subtract 25 from 49, you're left with 24. We haven't gotten to simplifying radicals yet, so when you take the square root of this, I'm okay with it as a decimal. It'll be 5.9 if you round. So then when you get this one, we're going to have to double that, so that's going to be 9.8. 9.8. And that'll be our length. That's our final answer. All right, next. So on number 13 and 14, you had to correctly identify which of these points was the incenter and which one was the circumcenter. Incenter is where all the angle bisectors meet, so this is K. Circumcenter is where all the perpendicular bisectors meet, so that is A. Number 15, this one was the one I went over in class that I said the diagram doesn't do it a lot of justice, but this line here, you can kind of see it. It's darker. It is not part of that line. This is also darker, not part of that line. So this is just showing a perpendicular distance from the sides, whereas these other three lines that are a little more gray in color are the angle bisectors. We know that these two are angle bisectors because they're labeled, so this point has to be our incenter. And if that's the incenter and this line is going from G to that point, this would also be an angle bisector. So first off, we know that this piece down here is 34, so that means both these angles are 34. So if we add them together, that's 68 for that entire angle. Then over here, we know that each of these are 36. So together, that's 72 for this entire angle. And once we know those two, add those together, subtract from 180. So that's 180 minus 140. Leaves us with 40. Oops. Yeah, leaves us with 40. And then we're going to divide 40 by 2 and get 20. So each of these is 20 degrees. Again, we found the difference. Divide that difference by 2. Gives us 20 total for each of those angles. On this one, again, now we're looking at these two pieces here. So these two pieces, since this is the end center, it is equidistant to the sides, so they have to be congruent. So if that one's 5, the other one's 5. There's no real work to be done on that. You just have to know your property. Number 17. The circumcenter of a triangle is on one side of the triangle. Explain how to find the area of the circumscribed circle of the triangle given the lengths of the sides. So let's see. The circumcenter of a triangle is on one side of the triangle. Explain how to find the area of the circumscribed circle. So on here, if we're talking about a circumscribed circle, the distance from the circumcenter is equidistant to all the vertices. So we would have to use the radius, or the distance from the circumcenter to any one of the vertices. Because if we have a circumcenter, it's equal distance to all the vertices. So let's draw a picture to help explain that. So if, now I'm not drawing the entire thing, but let's say that this is a circumcenter, and I drew a circle. That is our circumscribed circle. The distance to all the vertices is the same. Therefore, these would act as our radii, or radius. So when you find area of a circle, you'd have to use the distance from the circumcenter to one of the vertices as a radius. So use distance from circumcenter to a vertex as the radius. Again, formula for area of a circle, pi r squared. You just have to plug in the length of the radius. So that's what we would have to find. On number 18, 19. So which one's a median, which one's the altitude? The median goes from midpoint to opposite vertex, so WF or FW. And the altitude is the perpendicular line from one side to the opposite vertex. So EX or XE would be the altitude. 20 and 21, we did not focus on using points with orthocenter. We're going to do points with centroid, not really for orthocenter. So now in 22, reason. The orthocenter of ABC is point B. What is the measure of angle ABC? The only way that this will happen is if this is a right triangle. So the only way to get the orthocenter on a point is if we had a right triangle, because that would mean that the side here is an altitude, this side's an altitude, and they meet at the vertex B. So it is 90 degrees. So that one was making you think a little bit outside the box. Number 23, a plastic triangle is suspended parallel to the ground by a string attached to the centroid. Copy the triangle and show where the string should be attached. So you'd have to find the centroid of this. So where I'm just going to use I don't have a ruler up here. Alright. I'm just going to approximate for this one. But again, you could either do this through construction or you could measure this out. But the points that I am labeling right now, these would be my medians for each of those sides. And I need something as a straight edge. So then I would draw my lines in for my medians. So not perfect. I didn't use the best thing as a straight edge either, but that is approximately where my centroid should be. Is this going from vertex to midpoint? Alright, next. On 24, we have determine if the lengths can form a triangle. So you have to have any two sides be greater than the third side. So if we take the two smallest ones, add them together, and they're greater than the third side, then it makes a triangle. If it doesn't, then it doesn't make a triangle. So if we add 18 and 14 together, that gives me 32. It's not greater than 32, so that one does not make a triangle. On 25, if we add 14 and 25 together, 14 plus 25, that's going to be 39. That's greater than the biggest side, so yes, that makes a triangle. On this one, we have 22 and 37. If we add those together, we get 59, which is greater than that, so yes, that makes a triangle. On this one, 35 and 41. If we add those two together, we get 76, which is less than that side, so no, that one does not make a triangle. Again, the two smallest sides, so like if you wanted to show a reason why, you're adding the two smallest sides. On this one, they're equal. It's not greater than. On this one, 22 plus 37 is greater than 56, so that's why it was. 11 plus 25 is greater than 29. That's why it was. And then this one, 35 plus 41 is less than 87, so that's why it wasn't. All right, on the next one, which has the least measure? Which angle has the least measure? So look at the sides. This is a small side, so across from the small side, it would be the smallest angle. So Q has the smallest measure. Which has the greatest measure? Well, if this is the biggest side, across from that is R. Angle R should have the greatest measure. Why must the sum of two sides of a triangle be greater than the third side? So, in order for them to intersect, they have to be greater. So, in order to intersect and form a triangle. Yeah. Number 31, two sides of a triangle garden are 6, 4, and 6.2. The garden buys fencing per meter. What is the range of total cost of the fencing? All right, so this adds a little extra step to this. So in order to figure out what the third side would have to be, it has to fall between the sum and difference of those two numbers. So first, that third side has to be between. If we add these together, 6.4, or actually, sorry, I should put that on the top end, the sum, 6.4 plus 8.2. And on the bottom end, we're going to subtract the difference, so 8.2 minus 6.4. So this falls between, let's see, 6 and 8 add up to 14, so this is 14.6. This one would give us, that's 1.8. So that is the range for the side in meters, but they want the range of the cost. So we're going to have to multiply. So we're going to have to break out a calculator here in a minute. So we're going to have to go 1.8 times 29.25. And the other end of this range, 14.6 times 29.25. And I don't know if I have a calculator sitting up here. I do not. Let me go grab one real fast. Alright, so 1.8 times 29.25, 52.65. And the other end of the range, 14.6 times 29.25, 427.05. So there's a huge difference between those two costs, because both of those are in dollars. So somewhere between $52 and $427. Again, it all depends on what the third side of that triangle is. On 32, write an inequality for the possible values of x. So, looking at these two values, these two sides, well, which one's bigger? This one has to be bigger, this one has to be smaller. So, 3x minus 1 has to be less than 23. Now, you should include a bottom end because it still has to be greater than 0, because you can't have a side of a triangle that's 0 or even a negative number. So it has to be greater than 0. It has to be positive. So add 1. So we have 1, 3x. Add 1 to this side as well. Divide by 3. So x has to be greater than a third. It has to be less than 8. On 33, write an inequality possible for the values of x. So again, we have two congruent sides. And the side across from it, we have this one's bigger, so this one has to have the bigger value. So we're going to write 4x minus 7 has to be greater than 3x plus 6. So let's solve that. We have subtract the 3x, add the 7, and we get 1. So x has to be greater than 1 in order for that to work. Alright. Since x has to be greater than that value, we don't have to look for a bottom end of that range. Alright, and 34. Cameron incorrectly says the converse of Hinge theorem proves that angle S is less than angle W. Explain his error. So let's see. Angle S is less than angle W. Well, the one thing that's missing here, they don't tell us anything about the sides, and I don't even think that these two look congruent. In order for this to work, we have to have two congruent sides first. So like this one and this one has to be congruent, this one and this one would have to be congruent. So we need to know the sides next to the angle are congruent in the two triangles. Alright, something like that. And that's it for that review.